In this lesson, we're going to learn yet another way of solving a system of equations, but this time, instead of just using a matrix, we're going to use a matrix equation. So go ahead and pause the video and write the notes. Alright, so let's take a look at this very first system of equations right here. How can we change this system of equations into a matrix equation? Well, the first thing that you notice when you were writing your notes, we could change it into an equation that looks like matrix A times matrix X equals matrix B. Matrix A would be our coefficient matrix. So let me show you how to create your coefficient matrix. Your coefficient matrix contains all the numbers that are in front of our variables, and we have to keep them in the right column. So if we're going to write X first and Y second, we'll do that on the first row, and we have to keep the same order for the second equation. We have to write the coefficient in front of X first, followed by the coefficient in front of Y. Here X has a 5 in front of it, Y has a -2. Don't forget the sign right there. That's a -2. That's our coefficient matrix. I'll call it coefficient matrix. And we're going to multiply that coefficient matrix by a variable matrix. And in this case, our variables are named X and Y. So we'll create our variable matrix and put X and Y in here. And then we're going to set it equal to our constant matrix, and our constants are these numbers. So we'll create a constant matrix, 1 and 13. And this is the equation that we would set up, this is the matrix equation that we would set up for this system of equations. This is our variable matrix and our constant matrix. And why does this work? Well, if we went and actually did the multiplication here, we would end up, let me write this column up here, X and Y, we would actually end up with a matrix that looks like 2X plus 3Y. And on the bottom, when we did the bottom row, we would get 5X minus 2Y, and that matrix would equal the matrix 1, 13, which is the exact thing that we have over here in our system of equations. So let's go ahead and take a look at how we would do it for a system that looks like this. First off, we should have all of our variables on one side, and we have one of our equations that just doesn't cut the mustard. So we need to go ahead and move this 3c to the other side, because all of our variables should be on one side and our constants should be on the other side by themselves. So let's go ahead and fix this equation. This equation really should be 5a minus 3c equals 1. Now we can go ahead and make our coefficient matrix. We'll go ahead and take the numbers out in front of our variables. We have a 3, a 5, and a -12. Remember, we need to keep them in order. Our variable a is missing here, so the number in front of it would be a 0. 7 in front of our b, and 2 in front of c. And now in front of a for our third equation is a 5. We're missing a b term, so the number in front of b is 0, and the number in front of c is a -3. Our variable matrix would then be a, b, and c in that order, a, b, and c, and then that would be equal to our constant matrix, which is 6, 8, and a +1. And this is the matrix equation that represents our system over here. So I want you to go ahead and try and do that with this last system of equations.